So at the end of section 1.1, there's this excursion on KenKen puzzles, and there's a homework exercise to do a few of these. So I thought I would just illustrate how to do one of them. It's helpful actually with the Venn diagram problems that we're going to do later on in the semester. So even though these are sort of just a recreational kind of a puzzle, they have some benefit for solving the Venn diagrams, which is actually kind of a method that can be used. And it's just an exercise in deductive reasoning. So the way these puzzles work is, well, like in a 4x4 puzzle like this, you're going to put a number in each box, and it's going to be a number 1, 2, 3, or 4. And across any row, you cannot repeat a number. So all 4 numbers, 1, 2, 3, and 4, have to appear once somewhere in the row. And the same for the columns. You can't repeat numbers. All 4 of them have to appear. And we have these outlined sets of boxes. We call those cages. And this cage has a 6x written up in the upper left-hand corner. That means 6 multiplication. So the 3 numbers in the boxes have to multiply together to make 6. It would be 2 times 3 times 1, or else 1 times 2 times 3, or you could put them in any order here. It doesn't matter as long as the 3 numbers multiply to make 6. You could repeat numbers diagonally like this. That's okay. Now, so that's the whole thing. This one is 7 plus, so that means you need 2 numbers in this cage that add up to make 7. This cage just has a plain old 2 in it, and so that means that it's just a 2 goes there. All right. So the rules over here are: do not repeat any number in a row or column. The number in each cage, numbers in the cage have to add or multiply, have to combine to make the target number. And cages that have just one number in them, you just put the number in there. And a number can be repeated within a cage so long as it's not in the same row or column. Okay. So those are the rules. And then I want to come down here to the strategy. So start, you just, the single number cages are done already. So that's a 2 and that's a 1. And then you go to the cages that have just 2 squares in them, like this one or this one or this one or this one, because the small cages are usually easier to figure out. And we'll just start writing down some possibilities for what could be in there. I'm coming over to this one. It's either 4 times 1 or else it's 1 times 4. Cannot be 2 times 2 because then you'd have more than 1 2 in that column. So this is 1 4. Well, you can't really see that. Let me write better here. That's either 1 4 or else it's 4 1. Okay. And then here's this 12. That's either 4 times 3 or else 3 times 4. So, and then those two, they interact together, you know, because if it was 4 times 1, if it was 4 1 here, then this one's got to be 3 4. But if you flipped it, if it was 1, 4, then this would have to be 4, 3. So it's either the 4s, the two 4s have got to be on the diagonals here. It's either 4, 4 like this, or else it's 4, 4 like that. But either way, there's no more 4s off to the right-hand side. So I'm going to make a comment over here on the bottom 2 rows. There's no 4. Okay. I think I've lost my camera. Okay. So 4 times 1 or 1 times 4 over here. 4 times 3 or 3 times 4 over here. The 4s got to be diagonal. So there's no more 4s over here. Okay. Now let's see. Well, let's go. Well, this over here, the 7, it's either a 3, 4 up there or 4, 3. Okay. How about going up this way with the multiplying to make 6s? It's 2 times 3 times 1. Okay. But what have we worked out over here? The 1's going to be used up. So we got 2 times 3 times 1, but there's no 1 over here. Okay. So that means the 1's got to be there. So now this is 2 times 3, or else 3 times 2. Well, you see, you can't have the 2 here because there cannot be 2 2s on a row. So if it's 2 times 3 and there's no 2 here, this has got to be the 3, and that's got to be the 2. Okay. Well, let's see what we can figure about multiplying to make 8. So it's either 2 times 4 times, well, it's 2 times 4 times 1 some way. Okay. And the 4 can't be here. No 4s over there. So that's not a 4, and it's not a 1. So that has to be the 2. So now these are either 4 and 1, or else 1 and 4 in there. So whichever way it is, if it's 4 and 1 here, then up here it's 4 and 3. It's either the 4s are diagonal this way or that way. Okay. So we can't quite tell on that. Is it? Oh, we can, because these two entries are 4 and 1, but the 1 cannot be here. So this one's the 4, and that one's the 1. And that means this cannot be 4, so it has to be the 3. And then this one is the 4 over here. Okay. So what are these two numbers? They've got to be 2 and 3. You can't put the 2 here because of the row, so that's the 3. And this must be the 2 down here. Okay, now this is either 4 times 3 or 3 times 4. I mean 4 times 3 or else 3 times 4. It can't be the 3, so that 4's got to be up here for 3. Okay, and then for 1 there, and we're finished. So it's kind of a silly problem, but it'll help you with the Venn diagrams. And I mean, some people find these fun. I think they're kind of okay. Anyway, that's it for this recording.